All right, what's going on, guys? This is LeetCode 2059. It is the LeetCode of the day for July 5th, 2024. I'm going to be solving real quick. I read through the problem description and then immediately took a nap and woke up and solved it in like 5 minutes. It was insane. First time through, no syntax errors. So well, let's go. Let's see if we can repeat it for you. Let's just read the description real quick. A critical point in a linked list is defined as either a local maxima or local minima. A node is a local maxima if the current node is a value strictly greater than the previous node and the next node. A node is a local minima if the current node is strictly smaller than the previous node and the next node. Note that a node could only be a local maximum and minima if there exists both a previous node and a next node. Given a linked list head, return an array of link 2 containing min distance, max distance, where min distance is the minimum distance between any two distinct critical points, and max distance is the maximum distance between any two distinct critical points. If there are fewer than two critical points, return -1 and -1. Okay, so the first example, clearly there's not even enough nodes to compare to because you need 3 nodes to compare. So like in this example, number 1 right here would be one of the, what do they call it, a critical point, I think. Yeah, they're calling it a critical point. So yeah, 1 would be a critical point because it's less than 3, and then it's less than 2 as well. And then 5 would be another critical point, but only because it's greater than 2 and greater than 1. And then of course 1 would be 1 as well because it's less than 5, less than 2. So how are we going to solve this? Great question. Let's start by just doing an iterative approach through the linked list. So let's do like while head. We're going to start obviously at the head of the list, which is going to be 5, but we got to make sure that there's at least 3 nodes because as we know, 2 does not work. So let's do while head dot next. Okay, so that means if we have head and next, okay. And then I want to keep track of where I am in the list. So let's go steps equals 0. We're on the 0 spot. Super simple. And then obviously, no matter what we're doing, we're going to increment the steps each time, and we are going to update the head to the next value or the next node in the list. Super simple. So yeah, we're just doing the iterative approach right here, and then we need to keep track of basically 2 things here. We need to keep track of the minimum distance between any 2 distinct critical points and the maximum distance. So in order to keep track of the maximum distance, we're going to have a variable called first, and that's just going to be set to -1 if we haven't seen anything. But if we do finally see something that matches where it is a critical value, we're going to update that to whatever the steps are, and we're only going to do that once. So in order to set that, let's just see if we can write an if statement to find if something is a critical value, which should be pretty simple. We're going to do head dot next dot value. It's going to be less than head dot value, and the head dot next dot val is again less than head dot next dot. What's right? Next dot val. Okay. So this is going to make sure that the middle value, head dot next dot val, so right here it'd be like 3, is less than this value and this value. So that would be like a local minimum, a critical point with a local minimum. So let's do or and then do the same thing but flipped so that we can get a local maxima. Let's just control C that. And then it's going to run off the page, but we don't know correct Python syntax to tab it over, so we're just going to have to get through with this for right now. And then boom. So if that just defined that it's a critical point, either a local min or a local maximum. If we haven't found our first value yet, okay, if it equals -1, what we're going to do, we're going to set the first equal to step, and we might as well update. Oh, we're forgetting one more value. Let's type in the value name, but I gotta explain it first. What we need is a way to keep track of the last critical point that we saw if we're on one, so that we can find the minimum distance, right? So we're going to have a variable called recent, and it's going to be set to -1, of course. Might as well. And then we're going to set that equal to whatever step we're on at that point, because this is just the first one we've seen, so there's no point in updating the recent. And then if it's not the first critical point we've ever encountered, we're gonna need to update it to keep track of what is actually the minimum distance between the two critical points, and then the maximum distance between any two critical points. So let's make two more variables, min equals, and this one, I'm going to use a min function to update it. So we're going to set it as the float in infinite value. Pretty chill. And then we're going to have a max, and that's going to might as well just set it to -1, because we're going to update that each time anyways. And then we can go ahead and set min, since we've already found one in this section of the if statements. We're going to set to min of the m, already what we have, and then step minus recent. So that'll give us the minimum, if it is going to be minimum. And then max, every time we find a new one, it's going to be max, because it's always getting bigger. So we're just going to do step minus whatever the first one is that we found. Simple, right? And then one thing we have left is recent is going to equal step, right? Because that means we just found one, so we need to update recent as well. And then we can't have that below here. Like, we couldn't put recent equal step down here because we don't know if we're going to find one out here every single time, right? I think, and then we have the return statement, of course. We're going to return the min first and then max if we're going to say mx does not equal -1, because that means we found two values. Wouldn't use first or recent because we don't know. We could just find like one critical point, and then that wouldn't really mean anything for us. Excuse me. Else, we're going to return -1 and -1. And let's just try to run it real quick to see if we have any syntax errors. Click on step not defined. Yeah. We call it steps, which I would rather call it that, but whatever. I called it down here. I think we're good. Let's try it again. All right, so that's good. Let's submit it. Nice. Okay, so the runtime is 61 percentile, memory 61 percentile. That's there's something weird going on right now. Maybe LeetCode is having some buggy issues right now that looks really weird. I've never seen it in that kind of configuration before. But yeah, that was the answer. I somehow figured this one out quickly. The only hard part is just keeping track of like so many different variables right here at the top. It's kind of a lot to keep track of, but it's pretty straightforward once you actually think about it. If you had a better solution, let me know. Put your profile down in the comments. Check it out. You guys can check out my profile if you want. Chase. Yeah. All right, I'll see you guys later. Bye.